Hi, this is Don Nelson. I'm editor of the Additive Report, and I'm at FABTECH 2019. I'm at the HP booth with Tim Weber, who heads the HP Metals division, and ask you a couple questions here. This is your new machine. It's the Metal Jet. What can you tell me about it, and how is it different than other products on the market?
Yeah, so this is the HP Metal Jet machine that we're basically coming out with. We basically announced at IMTS here a year ago that we're coming out with this technology. It's a binder jet technology. So basically you start with a metal powder. We start with a metal injection molding powder. We basically spread that, and then probably I'll talk about some of the things that makes us different and differentiate it, but then you basically jet down a binder, you dig the part out, and you basically put it into a sintering furnace, and you get basically a final part like we see here.
Oh, okay.
Now one of the advantages or one of the differentiators is when we first started working on this technology, my boss at the time was, it needs to be disruptive, which means it needs to be 10x productivity, half the cost, and it has to be sustainable from an HP standpoint. Well, as you know, HP is a very large 2D printing company, and we're basically number one and number two in every single printer category, from the $100 printer you're very familiar with at home or in your office, all the way up to graphics printers that sell for $10 million. The key behind that, though, is we have an inkjet technology print head that's the same in all those. We're vertically integrated. We've always kept that basically in-house, and so we're able to use a page-wide inkjet technology, so you spread and then print. Basically in one pass. We get huge productivity on the order of 50 times faster than the systems that are out there today, and we've basically leveraging our inkjet chemistry as well, basically coming up with a very novel binder, which takes order of magnitude less than conventional approaches, which means you can make very large parts and do it very quickly as well.
Okay. One of the big things in 3D printing is to go to large volume printing, and consistency is a big part of that. How consistent is the current generation of 3D printers?
If you look at current, I don't want to say bash the current technology that it's out there, but it's a laser, a powder bed technology, and a laser isn't really as consistent as maybe you'd like to have, right? Because the way that melt beam works, it isn't always isotropic, meaning the material properties aren't the same in all three directions. It's a fairly large laser beam, and so you don't always get great tolerance stack, right? The beauty of our technology, again going back to 2D, is actually if you look at the signage here, right? It's all done with HP latex technology. The human eye is incredibly sensitive to a single missing nozzle, right? And so over the years, we've learned how to space these nozzles so we can put down those drops at about 20 microns. And the human hair is at about 100 microns, so it's very, very fine. That effectively becomes our tolerance stack. We're putting drops of binder down at 20 microns onto that layer, and that effectively establishes our tolerances. And if you're an automobile company or a medical company, you need to know that what is your 5 sigma distribution, and be able to prove that you're basically in there, so you can basically get into manufacturing. So we will be much tighter because of our inherent 2D technology as we get into it.
Okay. All right. Okay, with the new machine, has there been any uses for it? Who's using it and for what?
Yeah, so we've got a great example that we just announced last week. So we've been working with a couple partners, GCAN, which is a very large parts producer, and one of their customers, which is a VW. You've probably heard of them, right? Yeah. So it started in this 3-phase roadmap where we're starting to produce parts that are more cosmetic, then we're moving slowly to more and more functional parts. Ones that might be more lightweight and crash resistant, but they take a little bit of time to certify it in because we have to prove the tolerance stack and the specifications and so forth. But we recently they announced their new ID3 electric car, and we built 10,000 of these as basically giveaways for them. And you could say, well, it's just a toy, but what for us, starting to exercise what it takes to build 10,000 of these on a printer like that has really taught us what it takes. It's actually part of the roadmap to eventually producing many more of actually functional parts for VW through GKN.
And eventually full-size VW.
Exactly.
One thing that there's some disagreement about how green 3D printing is. Some people think that it's, you just use what you need, when you make a part, but others say that it's no greener than any other manufacturing process. What's your feeling about that?
I think it's a little bit of they're both right to some degree as well, right?
Yeah.
I'm very diplomatic, yeah. And so at the end of the day, if you're making a metal part, you still have to get metal ore out of the ground, you still have to process it, you still have to heat treat it, and you have to produce it. That inherently is not green, right? But at the same time, the power of 3D is that over time you're going to produce what you want, where you want it, when you need it, right? So you start to take waste out of the system, right? You only build exactly what you want. You're not shipping metal or parts around the world or what have you, and so that inherently will become greener. I think over time also as well, if you think about long tail, there's industrial equipment that people made 50 years ago that they still have to find parts for, right? At the point you can start to build that part when you need it, where you need it. You no longer have warehouses, you no longer have tools sitting somewhere, and that is inherently greener and more efficient as well. And then where it won't be diplomatic is as you start to do a lattice structure like this and start to take weight out of a system. If you're a car manufacturer, you're going to fundamentally improve your gas mileage. That is greener, right? Okay. And what we're finding with a lot of those guys, it's not only lighter, and you can kind of keep the strength by building a lattice structure such as this with the power of 3D, but also it's a good energy absorber, and it actually allows you to build more crash-resistant vehicles as well, right? So it's not so much a green story, that's more around keeping people alive, right?
Yeah. Okay. All right. Thanks very much.